All right, guys, so here's the Analyzing Periodic Trends project that we're going to be working on Monday and Tuesday, most likely. So if you were in second period, you did not get this yet because we took the test on Tuesday, or if you were absent on Friday, then this is what we did on Friday. So at least by Monday, you need to have the graphs done. There's two graphs we need to do. We need to do the atomic radius graph, so graphing the atomic number versus atomic radius for elements 1 through 54, and we need the graph of ionization energy, so graphing atomic number versus ionization energy for elements 1 through 54. So this paper tells you what to do and the questions you need to do about it, and then we got the graph paper, and then we have the data. So here is the data that you're going to have on there as well. So here's the calculated atomic radius, so here are the numbers: 53, 31, 167, 112, 87, and down here are the ionization energies and electronegativities. So hydrogen's is 1,314, helium's is 2,368, then it goes down to 519, to 900, 799, so it's the top numbers on this one that are the ionization energies. So the first one, we need to graph on this piece of paper right here. The easiest way to graph would be to graph across doing landscape mode, right, and then putting the atomic numbers down here. So you're going to graph atomic number down here on the bottom, and so I think there's 54 lines at least down here on the bottom, and then we'll do atomic radius over here on the side. And I think it works if all of them go by tens, because the highest one you need is rubidium. So yeah, I think if you do it by tens, it's easy to see over here on the side. So that's where you will graph your stuff. So this down here will be 0 and 0, and then this one will be 1, so that'll be hydrogen, right? Hydrogen's atomic number is 1, so we'll put 1 and 53 for our first one. And if we're numbering this by tens, 1, 2, 3, 4, 5, I think that works. So 53, 1, and 53 is right about here, so put a dot there. And then helium is number 2 and number 31. So we put number 2 down here, and we go up to 31. So 10, 20, 31. So there's our second dot right about there. You're going to do that for points 1 through 54. Put all the dots, and it's not just going to be a line, or, well, you'll see what it is when it finally gets there. Once you're done, you will connect all of the lines themselves. So 1 to 2, you'll connect, and 2 to 3, and 3 to 4, and wherever that happens to be. So connect all those dots. So that's for atomic number versus atomic radius. Same thing you're going to do for atomic number versus ionization energy. So ionization energy is at the bottom. Graph down here, it's the top number up here. This bottom number is electronegativity. So top number, ionization energy. So same thing, atomic number down here on the bottom. And over here on the side, we're going to have ionization energy this time. And again, we can just do 1 through 54 down here in the bottom, but now we're doing ionization energy, so the highest number we need is 2,368. So you'll have to figure out whatever the scale is going to be on this side, so that it can go up to 2,368 over here. I think we go by hundreds, it's fine. Yeah, hundreds are okay on the side this time. So like still 0 and 0 down here, and then 100 and 200 and 300 for our scale. We don't have to number every single one. So again, we will do hydrogen is number 1, and then we'll go up to, this time, a number for hydrogen is 1,314. So we'll plot that point on there, and then helium is 2,368, so we'll plot that for the second point, and then lithium is 519, so you go 3, 519, you get the idea. And again, connect the points, and that's what you need to have baseline done by Monday. If you wanted to go beyond that, what we're going to do on Monday is talk about the trends, right? So look at the atomic radius graph, that first graph that we will do. So this will be done on Monday. You'll have the graph on here, and then you'll be able to look at the trends. So explain the shape of the graph. Is it completely random, or is there some kind of order? Draw a circle around points for elements 11 through 18. So find 11 through 18 and draw a circle around those. And then what happens to the atomic radius? Does it increase, decrease, or stay the same? And then go ahead and go on through those. So we'll be looking at the rest of these and kind of going through them in groups on Monday. So at least you need to have the graph done, and then take a look at some of the other stuff on here as well. And I'll send you all of these materials in case you weren't here on Friday, or you were part of period 2, or if you lost them or whatever, you forgot to bring them home. Okay.